Dear student, this is our integer part 2. In this chapter, you have to learn closure property of integer, commutative property of integer, associative properties of integer, and additive properties of integer. First one, closure property of integer. Closure under addition. We have learned that sum of two whole number is again a whole number. For example, 17 plus 24, this is equal to 41. 41, which is again a whole number. We know that properties is known as a closure property for addition of a whole number. Similarly, we have to test the closure property under addition for integer. First one, 17 plus 23, this is equal to 40. 40 is again a set of includes in set of a integer, therefore which is again integer, so result is an integer. Next one, bracket of minus 10 plus 3 is equal to minus 7. Minus 7 is again an integer, so results is an integer. Third one, minus 75 plus 18, this is equal to minus 57, is again an integer, so result is an integer. By these three example, what do we observe? We observe that there is any pair of integer whose addition is again integer. Yes, we observe that any pair of integer is again a integer when we added both. Okay, can we say that integers are closure under addition? Yes, we can say that integers are closure under addition. Okay, similarly, integers are closure under subtraction. See the example above. 9 minus 3 is equal to minus 3, and 12 minus 3 is equal to plus 4. In this case, result is an integer, means both results are under integer, so there is any pair of integer whose subtraction is again an integer, so we can say that integers are closed under subtraction. Yes, we can say that integers are closed under subtraction. Next one, commutative property. We know that 3 plus 5 is equal to 5 plus 3, this is equal to 8. That is, whole number can be added in any order, it results is an whole number. In other words, addition is commutative for whole number. Similarly, we can test for integer. Can you say some example for integer? Also, we have 5 plus of minus 6, this is equal to minus 1, and next minus 6 plus 5 is equal to minus 1, means reversing the digits. The minus 1 in both case will get, so results is an integer. So 5 plus minus 6 is equal to minus 6 plus 5, okay, is an integer. Try the following example. Minus 8 plus 9 and minus 9 plus 8. In both cases, the results is an integer. The general formula for any integer a and b, we say that a plus b is equal to b plus a. Addition of integer is commutative. Next, commutative under subtraction. For example, 5 minus 3 is equal to 3 minus 5. In both case, in first case 5 minus 3 will get plus 2, but in second case will get minus 2. So here LHS is not equal to RHS. Okay, we say that integers are not commutative under subtraction. Next one, minus 7 minus 3, this is equal to 3 minus of minus 7. The here minus 10 plus 10 is not equal, so this subtraction is not commutative for integer. Similarly, take at least 5 different pair of integer and check it. Now we conclude that subtraction is not commutative for integer. Okay. Next, associative property. Observe the following. Consider the integer minus 3, minus 2 and minus 5. Look at minus 5 plus of bracket of minus 3 plus bracket of minus 2. Here minus 3 and minus 2 are, it comes under one bracket. In next case minus 5 and minus 3 it comes under second bracket. In the first sum minus 3 and minus 2 are grouped together, and in the second minus 5 and minus 3 are grouped together. We will check whether we'll get different result. Okay, let us check using the number line. Minus 3 plus of minus 2 is results a minus 5. Next minus 5 minus 5 is results a minus 10. Next one, first grouped minus 5 and minus 3, it is became a minus 8. Therefore minus 2 minus 8, it is again became a minus 10. In both cases LHS is equal to RHS. So associative property for addition is okay. Next, in both cases we get minus 10. That is similarly consider minus next example, minus 3 1 and minus 7. Minus 3 is taken or separate out, and 1 and minus 7 is grouped in first example. So minus 3 plus of minus plus of it is became minus 6, minus 6. In second case minus 3 and plus 1 is grouped together, it is became minus 2 and minus 7. In both cases the answer will be minus 9, which is some are different. Take 5 more example, we will not find any example for which some are different. Addition is associative for integer. In general, for any integer a, b and c, we can say that a plus bracket of b plus c is equal to a plus b bracket complete plus c. Next, additive identity. When we add 0 to any whole number, we'll get the same whole number. 0 is an additive identity for whole number. In additive identity, again for integer also. For example, observe the following and fill the blanks. Here I filled some. Minus 8 plus 0 is equal to minus 8. When 0 is added to minus 8, answer will be minus 8. Next, 0 plus of minus 8, again it is minus 8. Next, to minus 23 plus 0, answer will be minus 23, same as okay. Next, 0 plus of minus 37, again result minus 37. 0 minus 59, it is again minus 59. Next, 0 plus bracket of minus 43 is equal to 43. 61 plus 0 is again a minus 61. Next, any number 1 plus 0 is 1. So the above example show that 0 is a additive identity for integer. We can verify it by adding 0 to any other 5 digits. In general, for any integer a plus 0 is equal to a. or 0 plus a is equal to a. Next, let us see some example. Write down three pair of integer whose sum is minus 3. B. Difference is minus 5. C. Difference is 2. D. Sum is 0. Solution for this: A. Minus 1, take two pair of integer minus 1 and minus 2. When you add minus 1 and minus 2, result will be minus 3. And take minus 5 and plus 2. When you add minus 5 plus 2, the result will be minus 3. B. Difference is minus 5. Minus 9 and minus 4, take two pair. Minus 9 minus of minus 4 is equal to minus 5. And minus 3 and minus 5, take two pair. Minus 3 minus 3 is equal to 5. Next, C. Difference is 2. Take here minus 7 and minus 9. Minus 7 minus bracket of minus 9 is equal to 2. Next one, plus 1 and minus 1. Plus 1 minus bracket of minus 1. Again it is 2. D. Sum is 0. In this one, we have to take the reverse sign of a same digit. Okay. Minus 10 plus 10 is equal to 0. Plus 5 minus 5 is equal to 0. Can you write some more pair for these example? Okay. Let us solve some more example which are similar to your exercise. Write down a pair of integer whose sum is minus 7. Answer: pair of integers are, here I written three pair, minus 4 and minus 3, 9 minus 11, minus 10 and minus 3. When you add these three pair, the answer will be minus 7. Second example, write a pair of negative integer whose difference gives 8. Here I written two pair. Pair of integers are plus 16 and 8. Plus 16 minus 8 is equal to plus 8. Second pair, minus 8 minus 16 is equal to minus 8 minus of minus 16. This is equal to minus 8 plus 16 is equal to 8. Next, second one, B. Write a negative integer and positive integer whose sum is 5. Here I written two pairs. Pair of integers are minus 5, minus 10 and 5 is equal to minus 10 plus 5 is equal to minus 5. Another pair, minus 15 plus 10. Minus 15 plus 10 is equal to minus 5. Next, third example. In a quiz, a team A scored minus 40 plus 10 0 and team B scored plus 10 0 minus 40 in the three successive rounds. Which team scored more? Can you say that we can add integer in any order? Okay, solution: team A score minus 40 in first round, plus 10 in second round and plus 0 in third round. And similarly, team B scored plus 10 in first round, plus 0 in second round, minus 40 in third round. When you add these three score, the answer will be minus 30 for team A and minus 30 for team B. Means both teams scored same score. Okay. And can we say that we can add integer in any order? Yes, we can say that we can add integer in any order, because addition of integer is commutative and addition of integer is associative. Okay, thank you. Similarly, saw the exercise 1.2. Okay, you have to solve this exercise. Okay.